Let's look now at how the t-distribution tables work. Unfortunately, they're quite a bit different than how z-tables work, so I'm going to start out by comparing the two. On the left, we have a standard normal z-curve. And as you'll recall, the way the z-tables work is they give you the area to the left of a z-value. And that's our first big difference, because with the t-tables, they give you the area to the right of a t-value. But wait, there's more, and it gets worse. With the z-tables, we find the areas in this big section of the table, and the z-values are found in that header column and that header row. Now, with the t-tables, it's the t-values that are found in the main area of the table, and the areas are in the top row. What's in that leftmost column? Well, remember, there is not just one t-distribution, there are many. Each different degree of freedom gives you a different t-distribution, and the degrees of freedom are found down along that left column. So let's see some examples of how this works. First, let's find the t-value such that the area under the t-distribution to the right of the t-value is 0.10, assuming 15 degrees of freedom. In other words, we want to find the t-value right there that would correspond to area there to the right being 0.10. And to use the T sub alpha notation I mentioned at the end of the last video, that means we're looking for T sub 0.10. So let's go to our t-table and see how we're going to do this. We want the area to the right to be 0.10. Remember, the areas are found in that top row up here. So I'm looking for this guy, area being 0.10. But notice there's lots of t-values. Remember, the t-values are in the main part of the table here. There's lots of t-values that correspond to this area. That's because there's so many different t-distribution curves. We need to know which one we're looking for, and that's why we were told to assume 15 degrees of freedom. So finding 15 degrees of freedom on the table brings us to there. So I'm looking for a t-value that corresponds to area 0.10 and degrees of freedom 15, which brings me to this square, and I get 1.341. So we have T sub 0.10 is 1.341. In other words, if we're looking at the t-distribution with 15 degrees of freedom, the t-value that has area 0.10 to its right is 1.341. Let's try another one. Let's find the t-value such that the area under the t-distribution to the left of the t-value is 0.20, assuming 7 degrees of freedom. Now remember, the t-distribution is symmetric about its mean 0. So that means half the area is to the right. So the area to the right is 0.5 and the area to the left is 0.5. We're looking for a t-value that has less than half area to the left. We're looking to have area to the left being 0.20. And again, the reason I know this t-value is to the left of the mean is half the area is to the left of the mean, and we want less than that to the left of our t-value. Now the problem here, of course, is that our t-table only gives us areas to the right. But remember, just like the z-tables, or just like the z-curve, this is symmetric across that middle point. So if we find the t-value that has area to the right being 0.20, then all we have to do to get the t-value over on the left is just stick a minus sign in front of it. So if I find the t-value that has area 0.20 to the right, then the negative of that t-value will give me the t-value that has that area to the left. And again, that's because of symmetry, because of the fact that this curve is balanced, symmetric, exactly the same on both sides of that midline, and that midline is at 0. So let's go to our t-table and find the t-value that has area 0.20 to the right. We find areas in the top row, and the area I wanted was 0.20, so I'm looking at that box in the top row. Now, which t-distribution am I interested in? It's said to assume there were 7 degrees of freedom. So I go to the left column where the degrees of freedom are. I'm going to go across from that number of degrees of freedom and down from the area I want, and that gives me the t-value I'm looking for, 2.517. So again, what we've discovered here is that 2.517 is the t-value that has area 0.020 to the right. Therefore, the t-value we want that has that area to the left is I don't know how much sense this is making, so let me give you a couple to try. And if you can do them with no problem, that's great. If not, that'll help you know what questions you want to ask me about. They're very similar to the ones I just did, so I'll leave you to them, and I'll come back and do these at the beginning of the next video.